Thank you all for joining this webinar. This webinar will be talking about how we use multi-amplifier to do all our research or different kind of application. So my name is Mika Ching. I'm from GTech Hong Kong Limited. So let me introduce you to our company first in case you're not really familiar with GTech. GTech started about 20 years ago, so formed by Guger Christopher and Gunther Ellinger. So they all started in Austria. There are two companies, as you can see, in Austria, Europe. Then following a few years later, we started to expand our company to Spain to do more kind of research in Europe. Then because there's lots of demand for BCI and related stuff in the US, so we started a US company located in New York Albany. Just 2 years ago, I joined GTech and started the company for them in Hong Kong. So to support the region in Asia Pacific, including New Zealand and Australia. So you can see GTech is actually covering the whole worldwide area. In some countries, we do direct sales, and some, which is quite difficult for us, we do distributors. So feel free to contact us if you're around, and we can show you around our equipment. As you can see, we have a list of ongoing research projects, and most of them are carried out in Europe because as our company are based in Europe, it's easier for us to carry out equipment and do some prototyping and cooperation with different kind of companies. As you can see from the list, we do really a wide range of product. For example, the recovery, which is well known for the recovery of stroke patient. Our existing unit is for upper limb, so we are working on the lower limb now. And more people are asking for the FNIRS device with the EEG. So you can see we're doing quite different kinds of application, all based on EEG and BCI stuff. This picture shows one application, how we use BCI on artistic applications. So as you can see, this is a Cougar robot, usually used in industrial area for assembling or manufacturing. But we decide to control this kind of robot based on BCI or P300. So you can see the subject is wearing a cap with EEG channels at the back of his head. What he's doing is using the brain signal to control the machine for artistic expression. So he's painting using different color paints and showing off in one of the events. Another example would be this cyberphone, which is a competition, what we call brain race. So it was held in 2016 in Switzerland. So this subject actually, participant used one of our device called the USB-M, a wire device, as you can see the wire here. So what they're doing is a cooperation game. They need to complete some tasks using the brain power. So we measure the signal from the brain, convert it to some kind of output. And it's a race, so they need to concentrate on their behavior and thinking and to exercise some kind of output. So you can see the application of BCI is quite broad. As long as there's a machine, then you can always control it with some kind of signal. For some of you not really familiar with brain-computer interface BCI, I will give you a brief introduction. What we're doing here is measuring the signal from a subject. It could be EEG, what we are using for today's demonstration. It could be ECOG, which means open brain mapping. Which require open surgery of your scalp, then place a electronic grid to measure the passive signal from it. But we are not doing that because really often because of the requirement to do in a field hospital. So no matter what kind of brain signal, we can always put it through a computer, which includes an algorithm to extract some kind of special signal. It could be a spike or a specific bandpass filter to extract maybe alpha wave, beta wave. After the processing, we extract the signal, we feed the signal to a device. The control signal control the device for example, the artistic machine. You can command the device to do some rotation, forward movement, backward movement, different kind of command. This device performs the movement, then there's a feedback back to our subject itself. So the subject receives the feedback, and the brain might alter its signaling based on the feedback they receive. For example, if the feedback is an electronic stimulation, it may cause some kind of spike in some area of the brain. So you can see it forms a closed loop system, making the signal keep updating itself and keeping the command in control. One particular example I will list out today would be the recovery X for a stroke patient. So there will be two stimulation boxes attached to the patient left and right hand as the device. What we ask the subject to do is to perform a left or right hand imagination of dorsiflexion. So just like flexing your hand. When the subject performs such flexation, there will be some kind of spike of EEG data from the motor cortex around the middle branding of the brain. We measure that branding for this particular spike, feed it through to the device. The electric stimulator, stimulate the left or right arm, depending on the signal strength. So the feedback is the electric stimulation. The stimulation actually helps the subject to activate more in the motor region. So as a form of recovery of the brain for linkage between the muscle and the brain. So the 3P repeat the algorithm again and again for 240 times, forming a closed loop system. So moving on would be the main topic of today. How we use all this kind of device in a single computer, multi-device data acquisition toolbox, which is based on MATLAB. So we've done lots of research nowadays are asking us whether we can do multiple analysis on different amplifier. For example, 250 channels of portable system could be for Nautilus, for wireless devices on 4 different subjects, and all data synchronized through one computer. Or another example would be quite extreme, 1024 channels using a wire high amp. So lots of channels all feeding through the data to one single computer. So all of these are achievable through the multi-device data acquisition toolbox. So today I will go through some requirement for using this toolbox. For the installation part, I will partially go through by the menu. Then we'll see some real example how we run it through MATLAB. For the requirement, there are software and hardware requirement. The hardware part is for the computer. You can see it's quite basic because this software is only based on MATLAB. As long as you can run MATLAB smoothly, then we can assure you can run the toolbox itself. So just make sure you can your computer have MATLAB release of 2017A and with Simulink and signal processing blocklet. Your computer ideally should be Windows 10 with Windows 64 bits. That's all you need for now. So in the future, we will update the MATLAB version, maybe to 2019. It depends on the demand of our customers. So this is the toolbox. If you're not familiar with what we use for data acquisition, all GTAC device use a program called GNeT Access Server, which is written by GTAC. The server retrieves data from all sorts of GTAC amplifier. So the GNeT Access Servers actually facilitate simple and independent data acquisition from single or multiple devices over an internal network. So as long as all the devices connect to the single network, or at least projecting the data to that network, we can handle all sorts of data acquisition and signal processing, which is quite easy for the user to use. Since the data acquisition is realized over a network, it's really possible to collect different kind of data. Not only EEG, could be other body sensors from a different amplifier, to a single computer using using a network server. So using this Genie SS server, we can connect more than up to 4 devices through the MATLAB Simulink block. It provides actually graphical interface based on MATLAB interface. So for example, some cases we test is using one USB M with Nautilus, which I will do in later stage of today. Then we also test for Nautilus up to 256 channels, which works pretty perfect, and 2 high-M, which is up to 516 channels. So this is the Genie SS interface toolbox. So you can see it automatically search for all kinds of device listed here. So for this particular example, there's one USB M, a wired device, one Genie Nautilus, a wireless device with a serial number here. So it displays the status of the devices, whether it's in use or not. This one particular example, how we configure the channels. This is the multi-device toolbox with, just as before, one USB M and one Nautilus. So all the signal can be done in real-time analysis. It will be synchronized through our server, so there's no latency between the two devices. And everything, even though two amplifiers may have different sampling rates, but we can do all the synchronization through the server. So there are no major data loss. If you're really concerned about data loss, we also have a Simulink toolbox for data count. So we always know how much counts the amplifier sends out and receive. So for this example, the Nautilus feed to one displayer and record an independent MATLAB save file. Then the USB M to another visualization scope and to another data set. So following the example, today I will make a recording using a USB M as this one. This photo just taken from my home because I'm working at home now. So this is the USB M research version. Notice the serial number is 2018, which will be displayed later on MATLAB. So it allows us to measure 16 independent channels of could be EEG or other biosignals. The great thing about USB-M is it got 4 independent grounding. So for this instance, I'm using just one set of grounding. So you can always connect different kind of EEG with a different grounding or different kind of sensors, as long as the sensor is 1.5 millimeter touch-proof connectors. So the USB-M allows connection for 16 channels up to 64 channels. So you can set up for USB-M and synchronize all the data through hardware in this case. The second, one more thing to mention is today we're measuring ECG. So I've already connected the 3 electrode on my body now. So we'll measure the ECG data later on through the USB-M. The second device we'll be using today is the Genie Nautilus multi-purpose version. So the device I choose is a Sahara. So it's a dry-based metallic electrode, which is active. So the reason behind is I'm alone at home, so it's much more easier for me to wear a dry cap. So I don't need to gel myself, just need to connect the reference and ground electrode using the mastoid behind my ear. So this wireless device provides 8 to 64 channels of EEG. If you are the multi-purpose version, which means there's some kind of disconnectable electrode. You can also see the graph here. So normally there will be single wire to your EEG electrode. This particular version provides you disconnectable electrodes, which means you can also connect other kind of sensors like ECG, SpO2 sensors, heart rate sensors, all type of sensors with 1.5 millimeter touch-proof connectors. Although the thing is the grounding will be shared with the EEG, but you can do post-processing to referencing the grounding in later stage through your software. So yeah, these are the two devices we will use. Moving on, we'll be showing you how we do it through MATLAB. But beforehand, let me show you the user manual. There's something to notice. Coming with every software or hardware, we go with the user manual, stating out most importantly is the requirement of the hardware and software version. So make sure you got the correct version on your computer in order to use it. For installation, it's pretty simple. As long as you have MATLAB, you just need to install one simple toolbox. So it automatically add the path to your computer. But make sure you add the subpath to your MATLAB Simulink toolbox in order to close the function. So I will show you how we do in MATLAB right now. After opening MATLAB and you can search all the functions through the Simulink library. For my particular computer, you can see I've installed quite a list of libraries for GTAC. Some example would be today, like the G Nautilus. You can easily configure the example through wiring the two boxes together. Then, like one more common example would be the real-time analysis toolbox or the GHISIS. It provides toolbox for like different scope for displaying signals of different kind of filtering, FFT for signal processing. All of these can be done in real time for real-time processing and real-time feedback from the system. So today we're focusing on the multi-device toolbox. We already have a demo file for you to view. So I would just use the demo for easier demonstration purpose. So as you can see from the demo, just as the example I did before, when I double click on the multi-device data acquisition toolbox, of course, you need to turn on the amplifier first in order for the computer to search for it. Now, double click on it, it will search for a device on the server. So wait a second for it to pop out. Okay. So it will pop out with two amplifiers that it detects. The first one is a UR 2018, which is the same serial number on my USB amp. And the second one will be the Nautilus device. So it supports up to 4 devices as long as you attach the device to your computer. Just like other software application from GTAC, you can configure the number of channels. For this USB amp, there are 16 channels. But today, we are just using the last channels for one ECG measurement. The two others signal would be ground and referencing, which is not listed here. One great thing of USB amp is you can select the grounding between the channels. So you can independently measure grounding for group D for ECG, and ECG could be group ABC. So same thing for common referencing. So it's pretty easy to use. But today I'm just using it for ECG only. So there's no need for selecting grounding. But one thing we can notice is sampling rates for USBN. It goes up to 38 kilohertz, which is much higher than the Nautilus. When you see the Nautilus here, sampling rates, the maximum would be 500. So we are going to test if there are any discrepancy between the sampling rate. So maybe I tune it up, maybe double of what is the Nautilus. And in Hong Kong, the notch filter will be 50 hertz. So I highlight the channel I want to change, apply to the highlight, so you can see it change automatically. Bandpass filter is ECG, so I'm not going to do any bandpass. Should be fine for now. And you can also do bipolar signaling. Of course, you can also do active signal testing, just feeding some random testing signal to the channel to see if your USBM is really connected to your computer and all the signaling is good. So after it's done for the USBM settings, I can move on to the Nautilus setting. On this page, there are 8 channels of dry electrodes. So you can see here. By pressing Ctrl A, select all, I can select all the channels I want. Then also selecting the notch filter. I actually saved down the last setting, but just to I can always change it. And pass filter for EEG should be fine, 2 Hz to 30 Hz. Input range is talking about the amplification range for this device. Because it's a dry electrode, so we usually recommend having a amplification of 750 Hz or above. So just tune it up a bit. Some great thing about the Nautilus is already embedded with a acceleration meter, so you can always add the free access meter to monitor the head movement of your subject. Some other useful thing will be battery level because it's a wireless device. After charge up, you can use up to 8 to 10 hours. So if you want to monitor battery level, you can also add a channel behind it. Link quality is another important function to test the linkage between the receiver box and the sender box. Sampling rate could be either 250 or 500 Hz. Same as the USB-M, you can also test the signal by sending test signals through the receiver box. As it is a wireless device, so we provide range of wireless bandwidth for you to choose from in case there is some interference between the channels with other devices. But usually should be fine. In case something happens, just switch to another channel. So if everything is set up, I can just press OK. Then it will send the configuration to your devices. And you can, okay. So the USB-M is using an individual scope and the Nautilus is using its individual one. I've opened the signal right here, just to let you see. So this the ECG signal from the USB-M, the first version. You notice there's a small number here which display the number of channel you are feeding out. So for USB-M, there's only one channel, so there is no number here. For G Nautilus, there are 8 channels. So let me open the scope for you. Okay. So, yep, 8 channels for here, 1 channels for here. And always, same as other GTAC application, you can select the number of channel to be displayed and select the range and time scale. So you can see, although the sampling rate is different, but when everything is done via the Genie SS server, the signal are quite smooth altogether. Just some latency because not because of the software, but because of my computer. I'm just opening up too much things, and this is not my usual demonstration computer. It doesn't work this morning, so I'm quite nervous this morning. So channel 8 is a bit fluxy because I got really thick hair after not really going to trim it after quantization. So at the back of my hair, the signal is not really that good. So if I press on it, yep, it works pretty fine. So some simple testing for active electrode. For example, when I bite, the muscle signal should be stronger. So I bite. You can see the signal is really fast in response. One more test is the alpha signal. If I close my eyes, you can see the alpha wave really displayed here. So yeah, pretty easy to use in terms of here. I can stop it here and yeah, and then you see if I change up the USBM number of channels, what will happen. So all this metadata will save automatically to your computer. Of course, you can make everything into a single file after some configuration. So just tune up a few channels, although there are no signal from here. And yeah, I'll keep the same setting for the Nautilus. Wait a second. Okay, so you can see it updates the number of channel automatically to 4, although I only have one of the channels as active. Yeah, these are just noise based on the reference and grounding. So yeah, really straightforward application. Is there any questions on the multi-purpose toolbox? Feel free to type in the chat box so I can check your requests. Okay, if not, I will move on to one more topic, which is related to multi-device acquisition, which is called G-distributed EEG. So this application allows recording of data using the USB-M, the wire device, for from different distributed PC. So these all little components on the USB-M through one PC, and the data will be sent to the central PC, which we call evaluation PC, eval PC. So different type of data PC can connect to different kinds of channels number. The purpose here is the eval PC being the master PC. So it controls all the synchronization of different data PCs sending either through the Ethernet cable or through the network to the same IP server. So it allows synchronization data through OSC protocol for distributed system, and data transmit to the evaluation PC via UDP network interface. So some highlights here is allowing you to do multiple subject analysis or measurement, or doing the same task together, such as hyperlinking through different PC. And the synchronization rate will be plus or minus 2 sample at a hertz of 256, which is usually enough for doing measurement of eval potential for individual subjects. So same as before, there are some requirement. The requirement will be quite similar. As long as you can use MATLAB interface, then you can use this function. It's also a Simulink toolbox, so make sure you got this driver here. USB-M will be the required amplifier. I'm quite sure other amplifier will work as well, because we're using the same GNSS server, but we haven't tested yet. So in case if you are interested, just let me know and I can check for you. So this one example of how we are doing it. The eval PC, each data from each PC is streamed to the evaluation PC here. So everything is sent through and can be reviewed through the master PC. And what you need to do is to select the parameters for the receiver box and the sender box. So make sure they got the same IP address and sending to the same GNSS server. For the individual computer, there will be quite similar toolbox here, which use UDP send function. So all the signal will be measured, for this case, is a single amplifier. If you add the multi-module amplifier, just I demonstrated, you can add more signal here. So For this instance, we use block A and B as one EEG subject. We call it EEG 3. Block C and D of the USBM for subject 4. So 2 subjects on 1 USBM, and all the data transfer in online to the central PC using the same signaling server channels. So this is another application for you to use multi-device channeling. So not only locally, you can also do it wirelessly. So I think that's all for today's demonstration for using multi-device measurement and application. So if you have any questions, feel free to leave it in the comment below, and I will answer here for you right now. If you don't have any questions, just feel free to leave any comment underneath, and you feel free to go. If you have any question, yeah, just email me. And one more thing I would like to tell you is I'm not sure if you have received the spring school invitation yet. I guess most of you might have heard of it, because as we all know, most of us are staying at home right now. So GTEC have canceled lots of overseas conference. Our original plan to go to Taiwan for some visiting. But yeah, due to the cases right now, so I'm staying in Hong Kong for at least 2 or 3 more months. So we decided to open up our own conference, the BCI School, which will be next week. So if you're interested, just register here. I will send out the link below. So in this spring school, we will go through different kind of BCI functions. Of course, including what I talk about. So you can skip this session or that session. We talk about lots of interesting things. We are not really used to displaying so much stuff. We also invite some overseas speakers from different universities. So if you're interested in a particular day, just press it here, then we'll guide you through it. Beside all the BCI function, we are also doing some medical stuff. As you know, we have 3 types of medical device: the Recovery X, the MindBeagle, and the cortiQ. cortiQ is the open brain surgery devices used for neurosurgery, and Recovery X is for the stroke rehabilitation. MindBeagle is for the coma patient assessment. So if you're interested, just feel free to register, and let me know if you have any trouble registration. So I'll help you go through it. And I guess that's all for today's webinar. Thank you all for joining. I will stay here for quite a while in case you have any questions. So have a nice day and stay safe. Thank you.